So you've been learning about rocks and weathering recently, and I wanted to take the opportunity to show something to you interesting that relates to that. Now, this is quite useful for you to watch because we're going to look at some data, which means you're going to get to practice analysing a little bit of data, not in too much detail, but there's some interesting ways of visualising data we're going to see in this video. And we get to remind ourselves a little bit about one particular type of erosion, and that's this one, freeze-thaw erosion. So as a reminder, we have a small crack in a bit of rock, which could have been caused by it, dropping or rolling over or something like that. And when it rains, some water is going to collect into that crack. At some point, that rock might be in an area of the world where the temperatures get below 0 degrees Celsius, and at that point, the water is going to freeze. And what's interesting about water, one of the many things that's interesting about water, is that unlike most liquids, when it freezes, it takes up a larger volume than when it was liquid. Most objects, when they freeze, when they turn from liquid to solid, they take up less volume, but water takes up a greater volume. Now, knowing why that happens is really quite complicated, but it is very interesting. So if you'd like to know, please do research it. But the point here is water in that crack, when it freezes, it expands and it wants to take up a larger volume. And as it expands, it applies huge forces to the rock. And those forces can cause damage to the rock. Now, this happening once probably won't cause much damage to a rock at all. But if this happens over and over and over again, either over a number of nights where it's freezing during the night and it's warming up and melting during the day, or over the course of a number of seasons where it's freezing for long periods of time over the winter and then warm with liquid water for long periods of time over the summer, those repeated processes of melting and freezing cause repeated huge forces on the rock, which can cause it to break, as you can see in picture 4. Now, one of the reasons this is relevant to us is because this is one of the reasons that we get these things, potholes, which you'll find when you learn to drive are incredibly frustrating. They are little bits of broken road, where you can see one here where it's rained subsequently and been filled in with liquid water. Now, they're really frustrating because they can damage your car. If you go over them, your wheel can come out of alignment and you end up with one wheel pointing in a slightly different direction to the other, or it can damage your tyres, and it can be very uncomfortable for anybody in the car. And they form because of freeze-thaw erosion. There's tiny cracks in the surface of the road caused by all sorts of things. People, dropping things on it, and cars going over really fast can cause tiny bits of damage. But then water gets in, and then water freezes, and it expands, and that process, repeated, can cause this kind of damage. Now, one of the interesting graphs we're going to look at, or maybe not a graph, one of the interesting pieces of data we're going to look at, which I'm going to show you now, is a map of the United States of America. And it looks like this. Now, it's difficult to determine which roads have lots of potholes and which roads don't, because they're forming all the time and they get replaced, they get fixed all the time. The council are constantly out filling in potholes, and yet as soon as we have a spell of weather where it's going to be cold during the night, more potholes will form. So going out and doing a survey and counting the number of potholes per road is not an efficient way of working out where the potholes are. So what this person did, and I'll put a link to the source in the description, but what this person did was they looked at Twitter. And they looked at Twitter in the different states of the United States of America, and they counted how many tweets had the hashtag potholes in them. And they assumed, based on that the more tweets there were mentioning potholes, the more potholes there would be. People often like to complain on Twitter. Now, what you can see is a cluster of these states here, where there are lots of tweets about potholes. Now, we've got to think about why that might be. And being scientists, we shouldn't jump rashly to any conclusions. So it would be unwise of us for us to straight away go, oh, that must mean there are loads more potholes there than anywhere else. Because actually there's another explanation. Now, there's a lot of large cities in this area of the USA. Chicago and Washington, D.C. are both in that area. And more cities mean more people. More people mean more tweets. So the more people you have in a state, then you're obviously going to get more tweets. And the more tweets you have, some of those tweets are going to be about potholes. So it's important to us not to jump to any conclusions. However, if we look over on the west, the left-hand side over here, this is the state of California. California has Los Angeles, San Francisco, San Diego. It has lots of big cities. It has lots of people. Tens of millions of people live in California, and yet they don't tweet about potholes at all. And again, that could be for lots of different reasons. Maybe the councils take care of the roads better in California. But I think there's another explanation. And I'm going to invite you on a journey towards discovering it. I'm going to show you another map of the United States of America now. This one shows the average temperature in the summer. I'm going to show you, basically, where the warm states of America are. Now, down here, Alaska and Hawaii, they're put there so that the map of America can fit nicely on a piece of square picture like this. But Alaska actually goes way up here to the northwest, and Hawaii is way out here in the middle of the Pacific Ocean. So we can ignore those two. But what we can see from this is that the warmer states are towards the south, which could be expected. The closer you are towards the equator, the warmer it is. Now, what's important to note here is that we are in degrees Fahrenheit. So they're using a different temperature scale to the one we're used to. So this down here, Texas, where we're getting an average of 80 to 85 degrees Fahrenheit, that is sort of 30s, average of low 30s degrees. So it's still really hot, but not quite, not 80 degrees Celsius, because that would be ridiculous. Now, what I'm going to compare this with is a map of the winter average state temperatures. Because if we look at the winter temperatures, we can work out which states are likely to go through temperature changes that involve going below the freezing point of water. Because if we can identify those states, they're the states where we're going to get potholes, because water is going to freeze in those states. So let's have a look at the average temperature in winter in the USA. If you want a little challenge, pause the video and try and make some guesses about which states are going to be warmest in the winter and which are going to be coldest. Okay, let's have a look at the winter average temperatures. So here we go. Now, darker blue colours mean colder temperatures. So just out of interest, you can see Alaska, way up to the northwest, is really cold. And Florida, the southeast one, down here, it's not that cold at all. We're still 55 to 60 degrees there. Now, water freezes at 32 degrees Fahrenheit. We know it freezes at 0 degrees Celsius. On the Fahrenheit scale, that's 32 degrees. So we're looking for blues that are this colour or darker. And if you look, that's these states up here. So these are the states that are regularly going to be having water freezing during the night and melting during the day. And that is where potholes form. So you can see the hot states towards the south stay hot. California, remember that was the interesting one from the map of potholes, where we had lots of people in California, but we don't have many tweets about potholes. That's because in the winter, 45 to 50 degrees. It hardly ever goes below the freezing point of water in California, and so potholes don't form. Whereas up here, in these states, we are regularly getting freezing, which means we will have potholes forming, and it means you will find people complaining about them. So that's just a little interesting analysis of some data and a little reminder of what you've learnt about potholes.